This is proper wafting technique.
That is proper wafting technique.
You don't stick your nose in there. You waft. Hey everyone, my name is Chris Anderson. What comes to mind when you think of a chemist? You probably imagine someone in a lab mixing liquids to produce a chemical reaction. But what if I told you there was a whole branch of chemistry in which you didn't need liquid solutions? And it was easier, and it was more efficient, and it was better for the environment. Dr. James Mack is a chemist here at UC, and he has pioneered a brand new method for solution chemistry. Hey James!
Hey Chris!
How's it going?
Good, how are you?
Hey, I'm great. Thanks for inviting me to your lab.
Oh, since you're in the lab, let me first get you some safety glasses.
Oh yeah.
We always have to make sure we protect ourselves.
Safety first.
Safety first.
That's right. How do I look?
Look great.
And safe.
And safe.
So, what is mechanochemistry? I gotta say that right. Mechanochemistry. Did I say that right? Mm-hmm. Okay. What is that?
Well, mechanochemistry is sort of what it sounds like. You're using mechanical energy to do chemistry.
So energy that's moving things around.
Energy that's moving things around. So you're using mechanical energy to mix the chemicals around. So that's what mechanochemistry is.
So you've been using mechanochemistry in a brand new way. Tell me a little bit about that.
So normally when you do chemistry, you typically think of doing big flasks and things of that sort with a lot of liquids around.
Right.
Well, in mechanochemistry, what you do is you eliminate the liquids. So there's no liquid around, and it's just the materials that you want to use that you're mixing together to do chemistry.
So you're not pouring, things in different flasks or anything. You're just using the actual, I guess, chemicals without all that liquid?
Absolutely. So basically, if you can do that, then maybe you can change the way chemistry is done and make better chemistry or different kinds of chemistry than we typically do.
What sort of things are used in chemistry that could be bad for the environment?
So things like benzene, something like dichloromethane or chloroform, these are things that are called volatile organic compounds or VOCs. Sometimes if you go to the home improvement store, you'll see paint that says low VOC, or you might see other things that says low VOC. VOCs goes into our atmosphere and that have become ozone depleters. Some of them cause cancer. It's harmful to the environment. And so what we're trying to do is, how can we keep the things that are good to improve our life without introducing some of the harmful VOCs into the environment?
Well, can you show me a little bit of how this process works?
Absolutely, we're about to do an experiment right now.
Awesome, let's go do it.
Good. All right, so we're going to do an experiment, a mechanochemistry experiment. We have two compounds, vanillin and barbituric acid. We're going to take a little bit of our vanillin, and it's pretty much what you need for vanilla. We're using a flask typically. We're going to use a vial, and we are going to pour our material into the vial.
Okay.
We're going to take another piece of weighing paper.
Right.
We're going to tear our flask again, and then we're going to take our other compound here. And so here's our other white powder that we're going to use. We're going to measure that out, but we're going to pour that in.
Okay.
And then we have
this little guy here.
Yep, our ball bearing, and stick that in. And then we just put the top on.
That's it.
That's it. We're going to walk over to our milling machine, and we are going to set this in it and clamp it down.
Okay. So this just looks like a clamp.
Yep.
Attached to a motor.
Clamp attached to a motor, and then we're just going to lock it in place here.
That mechanical ball is going to shake it all around.
And then basically the motor is going to move things around, which is going to take that ball bearing and kind of move it all around. And that's going to mix the chemicals together. Then we're going to lock it up, and then we're going to roll. And then we'll come back in about 5 minutes or so, and then we'll see what we got. Right. So I think we're ready to stop.
Yeah, it's been about 5 minutes.
Yeah. So we're ready to stop. We're going to open it up and then unscrew our vial to get it out. So now we have it out, and then we're going to pop the top and open up, and so we got this nice yellowish compound.
So what is this then? So we had vanillin, and then we had barbituric acid. So They went through a chemical change.
Went through a chemical change, so you
Okay.
can see the chemical change.
And what did we create?
So basically, the two pieces came together. So it's an offshoot of the vanillin. So the two barbituric acid and the vanillin are now joined together.
Okay.
So they used to be separate compounds, and now they're joined together.
Which is a synthesis reaction.
With a synthesis reaction.
Okay.
And we could do more things. So if we wanted to add something to this, we could and stick it back in. And so the cool thing about this, and a separation from traditional, so normally we do it in solution, we'd have all this liquid, and then we'd have to get rid of the liquid to actually get our compound.
You don't have to. It's all right here.
It's all right here. And so
Oh,
here, still smells like that nice
but it smells a little different.
Smells a little different. It's a little chemical.
It almost smells like the cherry, like the fake cherry, like the cherry soap,
Yeah.
which is completely different than what it smelled like
Completely
before.
different what it smelled like before.
I love that smell. Weirdly, I love that smell. It's not like, I mean, it's a good smell, but it's a very sweet smell.
It's a very sweet smell.
That's
And
really
so
cool.
all we would need to do is we would scrape our material out, and then we're done.
Yeah.
And so this is all we need to do in this
That's amazing.
mechanochemistry.
I mean, you can tell it's like a whole it's a different color, different smell. You just created something brand new.
And it was pretty easy to do.
It was so easy.
So easy.
You just measured out your stuff and you put it in here.
Put it in here, put it inside the mixing mill, waited a period of time, and you could do reactions. Sometimes it takes 5 minutes, sometimes it takes 5 hours.
Yeah.
And it could go for that long, and then we take it out, we scrape it, we're done, and we're done.
That's it. I mean, and basically the time it takes to microwave popcorn, we've made a completely new compound.
Absolutely.
Without any solutions or anything like that.
Nope.
That's pretty awesome.
No VOCs. You
No
didn't see any
VOCs.
VOCs throughout the whole process.
So, James, what are some potential impacts of this really cool new method you've come up with?
Well, one of the major impacts is how much waste we can limit in the environment. So if you think about the amount of chemistry and chemical products that everyone has in their homes and how much is made, think about multiplying that by 22, and that's the amount of waste that's generated when you make a product.
Wow.
So you think about a large amount. And so 80% of that waste is the solvent. And so the idea is if you can reduce that number, then you could significantly reduce the amount of waste that generates. So you're talking about the order of 10 billion pounds of chemical waste that's generated.
Wow.
Of which 80% of that is these volatile organic compounds.
So you could shrink that down, by millions and millions of tons. I think in just like my toothpaste at home, just
That's
the
right.
amount of waste that probably went into making that toothpaste, you could shrink that down by quite a bit.
That's right. And so the other thing you're looking at is the social implications that come through.
Well, James, thank you so much for inviting me to your lab. I think what you're doing is really showing off the creative side of science and thinking of this new method of doing solution chemistry.
Perfect, and you're welcome anytime.
Thanks, and hopefully this goes to inspire kids to rethink ways we've always done things and find a new and better way to do science.
I really do hope so, and I think that's what we're going to need if we're going to solve some of the complex problems we have in our society.
Hey, I couldn't agree with you more. And thank you for watching, and we'll see you next time on Science Around Cincy.
Dude, nice technique there.
Are you guys ready?
So it smells very much like vanilla. So if you wash it.
Oh yeah, it does smell. It smells like vanilla.
Yeah.